History of the universe. The Big Bang Theory is the most frequently applied explanation for the formation of the universe. Before the Big Bang Theory was made, an astronomer Edwin Hubble used an extremely powerful telescope that made him look at distant galaxies. With this information, Edwin Hubble realized that there are billions of galaxies and the Milky Way is just one of those. A few years later, Edwin Hubble's discovery was used by a Belgian astronomer named George Lemaire. He formulated the Big Bang Theory.
It took a while, more than 7 days, to create the universe as we know it. The universe was born about 13.7 billion years ago in a massive expansion that blew space up like a latex balloon. And that explosion was the Big Bang Theory. Just after inflation, the universe was likely filled with a hot, dense plasma. But by around 1 microsecond or so, it had cooled enough to allow the first protons and neutrons to form. The first stars created bigger atoms and more clusters of atoms. That led more heavenly bodies being born, and then at the same time, galaxies were crashing and grouping together. As new stars were being born and dying, then the things like asteroids, comets, planets, and black holes were formed.
Singularity epoch. 10 to 43 seconds after the Big Bang was thought to be the beginning of the Planck era, when all the stuff was condensed into a single point of infinite density and extreme heat. During this time, quantum effects of gravity are thought to have dominated physical interactions, with no other physical forces having equivalent intensity to gravity. The temperature of the cosmos was low enough 1028 Kelvin that the electromagnetism and weak nuclear forces were able to separate as well, establishing two independent forces.
This started at 10:37 seconds where the stage change that caused the partition of powers additionally prompted a period where the universe developed rapidly. The cause of cosmic inflation in modern origin, the period of rapid sped up the development and it's driven by another character to join a cosmological cast, something many refer to as swelling and/or inflation. After swelling halted, the universe consisted of a quark-gluon plasma, just as any remaining rudimentary particles. Starting here ahead, the universe started to cool and matter combined form.
The universe temperature dropped, enabling an extremely low temperature which led to various effects. One of these effects are particle energies decrease as well and their present forms have changed as well. Another is that mass annihilation took place because the low temperatures did not suffice the creation of new proton-antiproton pairs. Consequently, the remains of the mass annihilations became stagnant and irrelative. After 379,000 years, electrons collided and formed a radiation named cosmic microwave background, which is also the oldest light in the universe, and it can be seen as far as 13.8 billion light-years, but has an actual distance of 46 billion light-years from the center of the universe itself.
The slightly denser areas of the universe relatively evenly scattered matter began to gravitational attract one another. As a result, they became even denser, producing gas clouds, stars, galaxies, and other celestial formations that we can see today. This is called structure epoch, because it was during this epoch that the present universe began to take shape. This is made up of observable matter dispersed in diverse formations varying from stars and planets to galaxies, galaxy clusters, and superclusters.